Hi, this is problem set from slide. I'm going to show how to solve it. This is explicit initial condition, one of a sample question. So you have this circuits in time domain. You have I of S, current source. We're trying to find V of t across the resistor, the 3 ohm on the top. So it does have initial condition. I of S equal 1 when t is greater than 0. And initial condition for IL, there was um, initial condition for the current through the inductor, and it's actually 0. And V of C, the voltage across the capacitor on the right, had value of 1. So now you redraw the circuit in Laplace domain, showing initial conditions. That's your first step. So I just have pasted the drawing here, and I'm going to change this to I of S. And 3 to 3, this will be SL, so that will become 8S. And this is a 3, just a 3. V T across, that will be, let's say, V of S that you're looking for. And this one will be 1 over SC, where C is, I'll rewrite it. So 1 over S, 1 over 24 Farad, that is 24 over S. So I'm going to write it 24 over S. But what else is missing? You need to kind of look at that there was no initial condition for this inductor, but there was initial condition for this voltage. So we do have to kind of redo by adding a voltage source. So I'm going to move this one down a bit and this whole thing down, but I will be adding a and for indicating for its initial condition, so that will be plus minus what would that be? Just 1. So initial, so right here what you write down is V at time equals 0, VC, actual value over S. So that is 1 over S. And also this I of S at t, if for greater than, when time greater than 0 is 1, so you can convert this as 1 over S. So this question gets interesting because we are interested in this V out. So we can kind of look at the left side of it, and we can also look at the right side of it. So let's call left hand side A and right hand side B. And replace this left hand side, the A side, with Thevenin equivalent. That will become plus, minus, and now you will have this. That will be still 3 ohm, but V Thevenin is I, the source, and I was 1 over S. So V Thevenin will be 3 over S. So you have 3 over S here. On the right side, now we have to look at what would be the Z Thevenin. So Z Thevenin for the B side, that will be 8S, the inductor, parallel with the capacitor. So how do you do that? You can treat it as just like a resistor, because as it is, it's a similar way for ones in a resistor in parallel. So impedance in parallel, you add those two in your denominator and you multiply on the numerator. So that cancels out, and when you calculate it, it will be 24 over S over S. That is 8. So these 8 cancels out. You end up with 20. Oops, I'm gonna write it in right. 24 over S squared plus 3, which is 24S over S squared plus 3. So you have on the right side, I draw that was 8S, and this was plus minus 1 over S, and that was 24 over S. Okay, so what do you get at the end? So now you have to find the B Thevenin on the right side. So looking into it, so 8S, that inductor in parallel with the capacitor, including the initial condition, if you kind of redraw it around, it looks like the one that I haven't drawn here. So you have 8S and 24 over S, those two impedance in series, and then we are trying to find voltage across this inductor 8S. So that is 8S over the total 8S plus 24 over S. Multiply by the voltage. Okay, you can kind of think of it across the whole thing. That would be 1 over S. So if you quickly calculate that, and 8 you can kind of cancel out, and then this S cancels out. So you end up with, it looks like 1 over S plus 3 over S. But you multiply both sides by S, you end up with S over S squared plus 3. That is your V Thevenin for the right hand side. So now putting it together, it will look like equivalent circuit. you can think of, you have that 3 ohm, and then on the left side you have 3, and you had B Thevenin for A side, and on here you have Z Thevenin on the right side with B Thevenin on the right side. So I'll put right now B Thevenin. There will be Z Thevenin B side, just indicating, and that would be Z Thevenin on the A side, and this will be B Thevenin on A side. So now from the picture we had D Thevenin A was 3, B Thevenin A was 3 over S, that was plus minus, and Z Thevenin B side, we just had it calculated up here. That was 24 S over S squared plus 3, and B Thevenin on B side was S over S squared plus 3. So let's put a current I here. The I is literally V equivalent total and Z equivalent total. So V equivalent is going this way. We have 3S minus S squared plus 3. So we'll still drawing in like this manner. Let's simplify first. That is S squared plus 3, 3S squared plus 3 minus S squared, which is 3S squared plus 9 minus S squared over S cubed plus 3S, which is 2S squared plus 9 over S times S squared plus 3. And let's do Z equivalent. Z equivalent total is, we had 3, and so 3 plus 3 plus 24S over S squared plus 3, which is 6 plus 24S over S squared plus 3, and we put it all together, S squared plus 3, 6 S squared plus 3 plus 24S, which is 6 S squared, 3 times 6, 18, plus 24S over S squared plus 3. So it will be nice to kind of pull these out and put it together. that will be 6 times s squared plus 4s plus 3 over s squared plus 3. This can be further reduced down to s plus 3 times s plus 1 over s squared plus 3. That would mean z equivalent total. And what is I? We said I would be this one divided by this one. So let's do that. I equal 2s squared plus 9 over s squared plus 3 divided by 6s plus 3 s plus 1 over s squared plus 3. Or we can simply, we could have simply written down as 2s squared plus 9 over s squared plus 3 times s squared plus 3, and just 6 times s plus 3, s plus 1. So let's look at this. Pyong, pyong. That goes. Here, I will be end up being 2s squared plus 9 over 6s times s plus 1 times s plus 2. Then what is v out, or v that we are looking for? That is I, z. I is this I, and then r was 3, right? So I just fixed, that was over 3 here and over here. I think there was a copying mistake from here to here, so I have corrected to be not 2 but 3. All right, and then this one cancels out. You end up with a equal 3 over 2. Let's look at b in similar manner. S squared plus 9 over 2 over, this time it's s times s plus 3. When s equal minus 1, that's what you're plugging in. So minus 1 squared plus 9 over 2 over minus 1 times minus 1 plus 3. That is 1 plus 9 over 2 over, that is minus 1 times 2, so that is minus 2, and that would be 2 plus 9 over minus 2. That is 11 over 4, and that with the minus sign. Let's keep going with the c. c would be still s squared plus 9 over 2 over s times s plus 1. And you plug in when s equal minus 3. So minus 3 squared plus 9 over 2 over minus 3 times minus 3 plus 1. So that is 2 times 6. So that will be minus 2 times minus 3. That will be 12. And this will be 9 plus 9 over 2. So 9 times 2. I'll just write them. That is equal to 18 plus 9 over 12. That would be 6. 3 times minus 2. So that would be 6. That will make 18 plus 9 is 27. 2 times 6 is 12. And you can further divide by 3. That will be 4. 9 4. So A is 3. B is minus 11 over 4. C is 9 over 4. You're plugging into that original equation. BL is 3 over 2 plus. Now it's minus 11 over 4 s plus 1 plus 9 over 4 s plus 3. So when you convert that, inverse Laplace of V naught is V naught of t, or just Vt, is 3 times minus 11 4 e to the minus t plus 9 fourths e to the minus 3, the whole thing u of t. And that is your final answer.